Let's begin with a very simple question. When you look at the moon at night, what are you actually seeing? It feels obvious. You point your finger and say, there it is. But what you are seeing is not the moon as it exists in that exact instant. You are seeing it as it was about 3 seconds ago. Light reflected from the moon takes about 3 seconds to travel through space and reach your eyes. That tiny delay is real. If the moon were to suddenly disappear, which it won't, we wouldn't know for more than a second. Now that delay seems small, almost trivial, but that's only because the moon is close. In cosmic terms, it's practically next door. Look at the sun. The sunlight warming your face left the sun about 8 minutes ago. If something dramatic happened on the sun, we would continue living normally for 8 minutes before we had any clue. Now stretch your imagination a little further. The nearest star beyond the sun, Proxima Centauri, is over 4 light years away. That means when astronomers observe it, they are seeing it as it was more than 4 years in the past. If something changed there today, we wouldn't know until years later. This is not a flaw in our instruments. This is not because our telescopes are weak. This is because light has a finite speed. It does not travel instantly. It moves at about 300,000 kilometers per second. That's incredibly fast. Fast enough to circle Earth about 7 times in a single second, but it is still limited. And that limitation changes everything. When we look deeper into space with powerful telescopes built by NASA, we are not just looking far away. We are looking backward in time. Some galaxies we observe are billions of light years away. Their light began its journey before Earth even formed. We see them as they were billions of years ago, not as they are today. So here is the quiet but astonishing realization: whenever you look into space, you are looking into the past. There is no way around this. Information about distant objects must travel to you, and it cannot travel faster than light. That delay between event and observation is built into the structure of the universe. In everyday life, we don't notice this. If a friend waves at you from across the street, the light reaches you almost instantly. The delay is so tiny that your brain treats it as immediate. Evolution shaped us for short distances and slow speeds. Our intuition works well for throwing rocks and catching balls. It does not work well for stars and galaxies. But the rule is always there, even when you don't notice it. Every time you look up at the night sky, you are not seeing a live broadcast of the universe. You are seeing a layered archive of moments that have already happened. The sky is not a window into the present. It is a collection of ancient signals still traveling, still arriving, still telling stories from long ago. Now let's take this idea and push it much further. Imagine Earth as a small, bright sphere floating in space. Not bright because it glows on its own like the sun, but bright because it reflects sunlight and leaks energy in many forms: radio waves, radar signals, television broadcasts, military transmissions, airport communications. All of this information spreads outward in every direction at the speed of light. Picture a growing bubble centered on Earth. This bubble is made of information. Its surface expands at 300,000 kilometers per second. After 1 second, it is 300,000 kilometers wide. After 1 year, it is 1 light year in radius. After 100 years, it is 100 light years across. Inside that bubble, other civilizations, if they exist, could in principle detect evidence that Earth is active. Outside that bubble, Earth appears silent and unchanged. Now let's consider distance carefully. Suppose there is a planet orbiting a star 65 million light years away. That is not a small number. 65 million years ago on Earth, dinosaurs were alive. Tyrannosaurus rex walked across continents. Flowering plants were spreading. Mammals were small, mostly hiding in the shadows. If an advanced civilization lives exactly 65 million light years away and points a fantastically powerful telescope at Earth, what do they see? They see Earth as it was 65 million years ago. They do not see cities. They do not see oceans filled with cargo ships. They do not see satellites orbiting the planet. They see dinosaurs. Not because time is running differently for them, not because Earth has gone backward, but because the light carrying the image of dinosaurs has just now reached them. The light carrying the image of skyscrapers has not arrived yet. It is still traveling. This leads to a strange but unavoidable conclusion: different parts of the universe have access to different chapters of Earth's history. To a civilization 1,000 light years away, Earth is medieval. To one 10,000 light years away, early human civilization has not yet begun. To 100 million light years away, Earth may still be a planet dominated by ancient reptiles. Distance is not just space. Distance is time. Now, we must be honest. Even with extremely advanced technology, resolving individual dinosaurs on a planet that far away would be unimaginably difficult. The planet itself would appear as a tiny dot. But in principle, the information about that era is embedded in the light still traveling outward. The past is encoded in radiation expanding through space. This is where our intuition starts to fail us. We think of the present as something universal. We assume that what is happening here and now is somehow synchronized with the rest of the cosmos. But physics does not support that assumption. There is no master clock ticking identically for every observer in the universe. There is no cosmic no that everyone shares. Instead, each location has its own local present, defined by what information has had time to arrive. When you truly understand this, the idea that aliens might see Earth's past stops being science fiction. It becomes a direct consequence of the finite speed of light. The universe is not hiding our present. It simply has not delivered it yet. Now we arrive at something even more unsettling. And this is where many people begin to feel that physics is turning philosophical. But it isn't. It is simply being precise. We casually use the word now, as if it refers to something universal. Right now, this moment, it feels absolute. It feels shared. You assume that when something happens here, there is a definite answer to what is happening everywhere else at the same time. But physics quietly removes that comfort. According to relativity developed by Albert Einstein, there is no single universal present that stretches across the entire universe. The idea of a global now does not exist in the equations. What exists instead is something called a light cone, a structure that separates events you can influence from events you cannot. Think about a simple example. A lightning bolt strikes two different locations on Earth at nearly the same time. If you are standing exactly midway between them, you might see the flashes simultaneously. But if you move toward one strike, you will see that one first. Move the other way, and the order changes. At everyday speeds, these differences are tiny and manageable. But at speeds close to the speed of light, the disagreement about what happens at the same time becomes real and measurable. Two observers moving relative to each other can disagree about whether two distant events happen simultaneously. Not because one of them is wrong, but because simultaneity itself depends on motion. This is difficult for the human brain because our brains evolved assuming time is universal and steady. In daily life, clocks on opposite sides of a city tick almost identically. The differences are too small to notice, so we build our intuition around that approximation. But in reality, time and space are woven together into space-time. Events that seem simultaneous to you may not be simultaneous to someone moving differently elsewhere in the universe. Now connect this back to aliens observing Earth. When we say aliens 65 million light years away see dinosaurs, we are not just talking about a delay. We are also acknowledging that their definition of right now slices through space-time differently than ours. Their present intersects our distant past. There is no contradiction here. Each observer has access only to events inside their past light cone, events whose light has had enough time to reach them. Everything else is outside their accessible reality. So when you ask, what is happening on that distant planet right now? Physics responds with a careful answer. It depends on your frame of reference. There is no single universal answer written into the fabric of the cosmos. This is not mystical. It is mathematical. It has been tested with atomic clocks on airplanes, satellites in orbit, and precise laboratory experiments. Relativity consistently matches observation. The difficulty is not in the equations. The difficulty is in letting go of the idea that the universe shares a single ticking present moment. Once you release that assumption, the picture becomes clearer and stranger at the same time. The cosmos is not a synchronized performance. It is a vast structure where every observer carries their own version of now, limited by the speed at which information travels. Now let's slow down and remove the dramatic imagery for a moment, because precision matters. When we say aliens might see dinosaurs, it creates a vivid mental picture. We imagine some distant beings looking through a telescope and watching Tyrannosaurus Rex walk across a jungle. But physics demands that we ask a harder question. Could they actually see that level of detail? Probably not. Earth is small. From even a few light years away, our planet is just a faint dot next to a much brighter star. From millions of light years away, it would be unimaginably tiny. Even our most powerful telescopes cannot directly image fine details on planets orbiting distant stars. We detect exoplanets mostly through indirect methods. By observing the slight dimming of a star when a planet passes in front of it, or by measuring tiny gravitational wobbles. To resolve an object the size of a dinosaur at tens of millions of light years would require a telescope with an aperture so vast it borders on the absurd. It would have to be larger than planetary scales. The engineering challenges alone are beyond anything we can realistically imagine. So what could aliens actually detect? If they had extremely advanced technology, they might analyze Earth's atmosphere through spectroscopy. Light passing through or reflecting off an atmosphere carries chemical fingerprints. Oxygen, methane, carbon dioxide, these leave identifiable patterns in the spectrum. A civilization could infer whether a planet has biological activity by analyzing these signatures. But again, they would be analyzing ancient atmospheric data. If they are 65 million light years away, the chemical composition they detect would correspond to Earth during the late Cretaceous period. Any industrial pollution we have produced in the last century would be invisible to them. It simply has not reached them yet. Now let's consider radio signals. Humans have been broadcasting strong radio waves for just over a century. That means our detectable radio sphere is about 100 light years in radius. Beyond that distance, Earth is radio silent. And even within 100 light years, the signal weakens dramatically as it spreads. Radio waves disperse with distance, becoming fainter and fainter. A civilization would need extremely sensitive equipment. And even then, distinguishing our signals from cosmic background noise would be difficult. So when people say, "Why haven't aliens contacted us?" Part of the answer may be simple physics. Our technological footprint in the galaxy is tiny, it is young, it is faint. It is still expanding outward. This brings us back to a key idea: the universe does not provide immediate visibility. Information is limited by distance and by the inverse square law. The farther away you are, the weaker the signal becomes. The result is a kind of cosmic privacy enforced by physics itself. Not because we are hidden deliberately, not because we are special, but because the structure of space-time limits who can know what and when. Aliens might exist. They might be intelligent. They might even be searching. But whether they can see us depends entirely on where they are standing in space-time and whether enough light, enough information has had time to reach them. Now let's focus carefully on something much closer to us in time, the so-called radio bubble of Earth. Human civilization has existed for thousands of years, but for most of that time we were electromagnetically invisible. Our conversations did not travel into space. Our wars, our music, our discoveries, they were confined to the surface of this planet. The only detectable signature we produced was the subtle change in our atmosphere from agriculture and early industry. Everything changed in the late 19th and early 20th centuries when we began generating strong radio transmissions. Suddenly, Earth started leaking structured electromagnetic signals into space. Television broadcasts, military radar, satellite communications. All of it began spreading outward at the speed of light. Imagine dropping a stone into a perfectly still pond. Ripples expand outward in circles. Earth's radio signals behave in a similar way, except they expand in 3 dimensions. They form an ever-growing sphere centered on our planet. If radio broadcasting began roughly 100 years ago, then our radio sphere now has a radius of about 100 light years. That means any star system more than 100 light years away has no access to evidence that we use radio technology. To them, Earth remains quiet. Inside that 100 light year sphere are thousands of stars. Some of them may host planets. If intelligent life exists within that region, and if they possess sufficiently sensitive instruments, they could, in principle, detect our signals. But even here we must be cautious. Radio waves weaken dramatically with distance. As they spread outward, their energy disperses over an ever-increasing area. By the time they reach dozens of light years away, our strongest broadcasts become faint whispers buried in cosmic noise. Detecting them would require enormous antennas and deliberate effort. It is entirely possible that our signals are already too weak to stand out clearly beyond a certain distance. Now extend this logic further. Suppose there is a civilization 500 light years away. They are not receiving our radio broadcasts. They are not seeing city lights. They are not detecting satellites. The most recent light from Earth reaching them left our planet in the 1500s. From their perspective, the Renaissance is unfolding. Telescopes have not yet been invented. Electricity is unknown. If there is another civilization 5,000 light years away, they see Earth during ancient history. Writing may have just emerged. Empires are rising and falling. They have no evidence of modern industry. And if a civilization exists 100 million light years away, the light reaching them shows a planet ruled by reptiles and primitive mammals. Each distance corresponds to a different chapter of Earth's timeline. This creates a profound asymmetry in awareness. Even if the universe is filled with intelligent beings, the odds that two civilizations are close enough in both space and time to detect each other are small. Technology must overlap. Signals must be strong enough. And the civilizations must survive long enough for their signals to intersect. This is not pessimism. It is geometry combined with finite speed. Our radio bubble is not a declaration shouted across the galaxy. It is a fragile, expanding shell of information. Beyond it lies silence, not necessarily empty of life, but empty of our present. And somewhere, perhaps, there are observers who see a version of Earth that no longer exists, unaware that the planet they are studying has already changed beyond recognition. At this point, the physics itself is not complicated. The equations describing the speed of light and the structure of space-time are well tested. The real difficulty lies in something else entirely, our intuition. Human intuition was shaped by evolution on a small planet over short distances at slow speeds. If you throw a stone, it travels a few meters and lands. If you shout, someone hears you almost immediately. If you look at a mountain, you are seeing it essentially as it is right now, because the light takes only a tiny fraction of a second to reach you. In this environment, it is perfectly reasonable to assume that the world you see is the world as it exists in the present moment. The delay between event and perception is so small that it does not affect survival. Natural selection had no reason to equip us with instincts for relativistic spacetime. But the universe does not scale in a friendly way. When distances stretch to light years, millions of light years, billions of light years, the tiny delay that was once negligible becomes enormous. The same rule applies, but the consequences are magnified beyond anything our brains evolved to handle comfortably. We struggle because our language reinforces the illusion of a shared present. We ask, what is happening on that planet right now? The question feels natural. It feels meaningful. Yet in a relativistic universe, the question has no single objective answer without specifying a frame of reference. Even more unsettling is the idea that observers moving relative to each other can disagree about the order of distant events. This is not a trick of perception. It is a measurable feature of spacetime confirmed by experiment. Satellites in orbit experience time slightly differently than clocks on Earth. Aircraft flying at high speed accumulate tiny differences in elapsed time compared to stationary clocks. These effects are small, but they are real. Our difficulty, then, is not with the math. It is with abandoning the idea that time is absolute and universal. We instinctively imagine the universe as a stage where everything is happening simultaneously, just spread out over distance. But physics suggests something different. The universe is more like a vast network of events connected by signals, each limited by the speed at which information can travel. Your knowledge of distant events is always incomplete and always delayed. There is no way to step outside this structure. No vantage point allows you to see the entire universe. It is now. This is deeply counterintuitive because it challenges a quiet assumption that reality is synchronized. Instead, reality is layered. Each observer carries a personal horizon defined by how far light has had time to travel. Beyond that horizon lies not emptiness, but uncertainty, events that may have already occurred, but whose signals are still in transit. The struggle to grasp this is not a failure of intelligence. It is a reminder that our brains were built for forests and rivers, not for galaxies and expanding spacetime. The universe is under no obligation to match our instincts. Let's pause and separate imagination from established knowledge. What do we actually know with confidence? We know that the speed of light in vacuum is constant and finite. This is not speculation. It has been measured repeatedly with extraordinary precision. It does not depend on the motion of the source or the observer. Whether a star is moving toward us or away from us, the light it emits travels at the same fundamental speed once it is in empty space. We also know that no experiment has ever demonstrated faster than light transfer of information. Particles can exhibit strange quantum correlations, but those correlations cannot be used to send usable information faster than light. Every reliable test so far supports the conclusion that the speed of light is a hard limit for causal influence. We know that when we observe distant galaxies, we are seeing them as they were in the past. This is not a theoretical guess. It is directly confirmed by observation. Some galaxies appear younger, more chaotic, less structured. The farther away they are, the further back in cosmic history we are looking. Large space observatories operated by NASA have photographed galaxies whose light has traveled for more than 13 billion years. These are not present-day images. They are ancient snapshots. We also know that Earth emits radiation into space, reflected sunlight, infrared heat, radio transmissions. These signals spread outward continuously. If an observer is sufficiently close and technologically capable, in principle, they could detect those signals once the light reaches them. Now let's be equally honest about what we do not know. We do not know whether intelligent extraterrestrial life exists. We have discovered thousands of exoplanets orbiting distant stars. Some of them lie in regions where liquid water could exist. But we have not yet found direct evidence of life beyond Earth. We do not know how common technological civilizations are, or how long they typically survive. A civilization may arise and disappear in a brief cosmic moment. If technological phases are short-lived, the overlap between two civilizations' detectable periods might be extremely rare. We also do not know whether our current understanding of physics is complete. History shows that scientific theories evolve. Newton's laws were not wrong. They were incomplete. Einstein's relativity refined and extended them. Quantum mechanics reshaped our understanding again. It is possible that future discoveries will reveal deeper layers of reality. But any new theory must agree with the enormous body of experimental evidence supporting relativity and the finite speed of light. You cannot casually discard a framework that has passed every precision test for over a century. So when we discuss aliens seeing Earth's past, we are not indulging in fantasy. We are applying well-tested physical principles to hypothetical observers. The uncertainty lies not in the speed of light, nor in the time delay of signals. The uncertainty lies in whether there is anyone out there to receive those signals at all. Physics provides the structure. The existence of observers is an open question, and that distinction matters. Now let's move into even stranger territory, but stay disciplined. Imagine a civilization located 10 million light years away. They have instruments far more advanced than ours. They analyze the faint light from Earth and carefully decode the spectrum of our atmosphere. They might conclude that oxygen is abundant. They might detect water vapor. Perhaps they infer biological activity. But everything they conclude describes Earth as it was 10 million years ago. Suppose, hypothetically, that humanity had gone extinct 1 million years ago. That distant civilization would still believe Earth is full of life for another 9 million years. Their data would be accurate, but only about the past. This highlights something subtle. Observations are always local and timed. They are valid descriptions of signals received, but they are not necessarily valid descriptions of the current state of the distant object. We are used to assuming that seeing is knowing, but at cosmic scale, seeing is knowing the past. Now consider the reverse. We observe a distant galaxy 100 million light years away. We see spiral arms, glowing clusters of young stars, clouds of gas. We describe it confidently. We classify it. We measure its redshift and its rotation. But what if that galaxy has since collided with another? What if it has already transformed dramatically? We would not know. We are locked into the information that has arrived. This does not make astronomy meaningless. On the contrary, it makes it precise. We are reconstructing a timeline of the universe by observing different distances. But we must always remember what we are actually measuring: ancient light. Here is another thought experiment. Imagine a perfectly reflective mirror placed 50 million light years away from Earth. Light leaves Earth, travels to the mirror, and reflects back. The round trip takes 100 million years. If intelligent beings still exist on Earth at that time, they could, in principle, observe their own distant past. They would see dinosaurs. They would see continents in different positions. The past would not have reappeared. It would simply have returned in the form of delayed information. This suggests something profound. The past is not stored in some hidden cosmic archive. It is continuously radiating outward. Every event that emits or reflects light sends information into the universe. That information keeps traveling until it is absorbed or scattered. In that sense, the universe is filled with expanding shells of history. However, we must avoid a common misunderstanding. The fact that information about the past still exists in transit does not mean the past still physically exists somewhere. The event happened once. The photons carrying its record are what persist. There is a difference between an event and its signal, and that distinction forces a deeper realization. The universe we experience is a patchwork of signals at different ages. Every observer is embedded in a web of delayed information, never accessing the whole picture at once. This is not poetic language. It is a direct consequence of finite signal speed and vast distance. The universe does not hide its past, it broadcasts it. But it never broadcasts the present instantly. Now let's push this understanding further and consider the structure of the universe as a network of delayed signals rather than a synchronized stage. Every observer, whether human or hypothetical alien, is limited by how far light and other forms of information have traveled. The events that are happening right now on Earth, the building of cities, the planting of crops, the launch of satellites, are invisible to anyone farther than the distance light has traveled since those events occurred. Each civilization, each observer, has its own accessible slice of the universe, defined by their position in space and the signals that have reached them. Imagine that somewhere, a civilization exists 50 million light years away. They point the most advanced telescopes at Earth. The photons they are detecting left our planet 50 million years ago. Their observations are accurate. They can reconstruct climates, ecosystems, and perhaps even some geological events. They might detect the spread of flowering plants or the dominance of dinosaurs. They might even infer patterns in continental drift. But all of this knowledge represents a history that no longer exists. The Earth they see is gone. Humanity, mammals, even modern plants do not exist in that snapshot. Yet, to them, that is reality. This demonstrates a fundamental asymmetry. Observation is always delayed, and the universe at any given point is a mosaic of times, not a single synchronized moment. Every measurement in astronomy, every observation of distant stars and galaxies is similarly constrained. When we observe the formation of a galaxy 10 billion light years away, we are witnessing the earliest stages of star formation. Those stars are no longer young. Many have already aged, evolved, or exploded as supernovae. But the light that reaches us is fixed at the moment it left, encoding a past that is immutable from our point of view. It is a window into history, not the present. Each photon acts as a messenger, traveling across time and space, carrying with it the record of an event that has already transpired. The farther away we look, the further back in time we see. Our telescopes are not only instruments of observation, they are instruments of cosmic archaeology, unearthing ancient signals frozen in their journey across the universe. The implication of this is profound. The universe is not a single, unified, now, it is a network of local presence, each observer existing within their own light cone. Everything outside an observer's light cone is unknown until signals arrive. This limitation is not temporary or technological, it is fundamental. No faster than light travel or communication has been observed, and physics strongly suggests that information cannot exceed the speed of light without violating causality. Every civilization is, therefore, confined to the history that has reached them. The present, in the universal sense, does not exist in a way that can be accessed or shared. Each observer's now is necessarily local. This perspective changes how we think about the universe and about ourselves. Every star we see is a memory of itself. Every galaxy is a record of the past. The universe is filled with delayed histories, each traveling outward indefinitely, intersecting at different times with different observers. To truly understand reality at a cosmic scale is to accept that the present is an illusion beyond our local experience. What we perceive as real is shaped by signals that left their sources millions or billions of years ago. The universe is a web of interconnected light cones, a tapestry of time, delayed information, and within that web, our understanding is necessarily partial, limited, and always historical. Let's now explore one of the most mind-bending possibilities, a scenario that stretches the imagination but remains entirely within the rules of physics. Imagine an enormous, perfectly reflective mirror placed 50 million light years away from Earth. It doesn't exist, of course, but it serves as a thought experiment. Light leaving Earth travels outward in all directions, some eventually reaching this mirror. When the light reflects, it begins a long journey back toward Earth. A total round trip for that light would take 100 million years. Suppose humanity still exists at that distant time. Using a sufficiently powerful telescope aimed at the mirror, in principle we could observe the Earth of 50 million years ago, the age of dinosaurs. The photons returning from the mirror carry the exact record of events from that ancient era, continents in different positions, giant reptiles roaming the land, forests and rivers of a prehistoric Earth. Nothing about the present would be visible. There is no time reversal, no duplication of the planet. The past is simply reaching us after an enormous journey across space. This thought experiment illustrates a profound point: the past is not lost. Once light leaves an event, it continues traveling indefinitely, unless absorbed or scattered. The moment has passed, but its information persists in the universe. Every photon emitted or reflected carries a record of that moment, spreading outward like ripples in an infinite cosmic pond. Even if the original event no longer exists, the information about it is still out there, propagating through space. In a sense, the universe is a vast archive of its own history, continuously broadcasting the story of every light, emitting or reflective event across billions of years. It is important to understand that this does not imply that the past physically exists somewhere frozen. The dinosaur that walked across the Cretaceous plains is not still alive in some hidden corner of space. The continents do not remain in the same positions. The oceans are not the same. The event itself occurred once and is gone. What persists is the record carried by light and electromagnetic radiation, continuously traveling through the cosmos. That is the distinction. Events happen and end, but their signals propagate endlessly. The universe, therefore, is filled with expanding shells of historical information. Every star, every planet, every object that emits or reflects light contributes to this immense tapestry. When we look into space, we are witnessing a hierarchy of time layers, from nearby stars that show their recent past to distant galaxies that reveal epochs billions of years ago. The observable universe is essentially a mosaic of ancient snapshots, each intersecting with our own light cone to create the version of reality we perceive. Understanding this also reframes how we think about observation and causality. No observer has access to a global present. Each observer's know is local, defined by the light and information that have reached them. Every signal that travels through the universe represents a past moment, a piece of history moving outward. The present, in the universal sense, is inaccessible. Reality at cosmic scales is therefore a network of delayed interactions. And what we see anywhere beyond our immediate surroundings is always a historical account, never a live broadcast. This realization challenges everyday intuition. It forces a shift from seeing the universe as a synchronized stage to seeing it as an intricate web of light and time, where every observer experiences their own slice of history. Every photon is a messenger from the past, every observation a glimpse of what was. Our universe is a dynamic, layered chronicle, a living record of its own history, continuously unfolding across space and time, with the present existing only locally, never universally.